Welcome back to the channel. In today's tutorial, I'll be showing you how to create X-ray vision inside Unreal Engine 5, a really cool mechanic that lets you see enemies or objects through walls. We'll be building everything step by step using blueprints, so no coding required. By the end of this video, you'll have your own working X-ray system that you can drop straight into your project. Let's jump right into it. Open your project settings and search for Stencil. Under Custom Depth Stencil Pass, change it from Enabled to Enabled with Stencil. This allows us to use custom depth and stencil values. Next, open the content drawer and create a new material parameter collection. Name it MPC_X-ray Vision and open it. Inside, add a scalar parameter and call it X-ray ON. This parameter will control when the X-ray effect is active or not. Now open your character blueprint. In the Details panel, search for Custom Depth and enable Render Custom Depth Pass. This makes your character or object visible to the X-ray system. In the event graph, right-click and add a keyboard event X. This will be the key we press to toggle the X-ray vision on and off. From this node, add a flip-flop. From the A output, add a Play Sound 2D node and assign your X-ray on sound effect. Then add a timeline and open it. Set the length to 0.5 seconds. Add a float track and create two keys, one at time 0 with a value of 0, and another at time 0.5 with a value of 1. Select both keys and set them to auto for a smooth transition. From the update pin of the timeline, add a set scalar parameter value node and also connect it to the finished pin. Set the collection to MPC_X-ray Vision and the parameter name to X-ray ON. Connect the float track output to the parameter value input. Finally, duplicate the Play Sound 2D node and set its sound to your X-ray off sound. Connect this to the reverse input of the timeline. Now when you press X, it will play your on sound and fade in the X-ray effect, and when you press it again, it will play the off sound and fade the effect out. Now let's set up the X-ray vision material. Right-click in the content drawer and select Material. Name it M_X-ray Vision and open it. In the Details panel, change the material domain to Post-Process. Scroll down to Blendable location and set it to Scene Color before Bloom. This ensures the effect is applied to the scene before any bloom or lighting is calculated. Right-click and add a Scene Texture node. Set the Scene Texture ID to Post-Process 0. From the color output, add a component mask and tick only the B channel. Drag out from this and add a Blend Overlay node. Then create a constant 3 vector with values 0.05, 0.1, and 0.2 to act as a subtle base color. And another constant 3 vector with values 0, 0.9, and 1 as a highlight color. Connect both vectors into a lerp node, and then connect the lerp output into the blend node's V3 input. Next, right-click and add a constant 2 vector, and connect it to a Fresnel node. Connect the Fresnel output to the alpha input of the lerp. Set the base reflect fraction to 0.15 to control how strongly the rim light appears. Right-click and add another Scene Texture node, setting the Scene Texture ID to World Normal. From the color output, add a component mask and tick only the B channel, Then connect this to the normal input on the Fresnel. This adds depth to the X-ray effect based on the object's surface normals. From the blend overlay result, add a lerp node. Right-click and add another scene texture node. Set its ID to post-process input 0. From the color output, add a component mask and tick B. Drag this into a blend overlay node and connect it to the B input of the lerp. Then, from the mask again, add another lerp. Create a constant 3 vector for color 1 and connect it to this lerp. Then create another lerp for color 2 and connect it to the blend V3 input. Next, right-click and add a scene texture node, set the ID to custom stencil. From the color output, add a component mask, then drag this into a clamp node. Connect the clamp output to the alpha inputs on the lerp nodes for color 1 and the lerp after the blend overlay. From the component mask again, subtract 1, then clamp the result and connect it to the alpha input of color 2 lerp. This ensures that only objects with the correct stencil values are affected by the X-ray effect. Now, from the lerp output, add a multiply node. From B, add a sphere mask node. Connect screen position to A. Set a constant of 0.5 for B. Another constant of 0.8 for radius. And minus 0.5 for hardness. This creates a circular mask for the effect on the screen. Finally, right-click and add another scene texture node, set the ID to post-process input 0. From color, add a component mask and tick B. From this, add a lerp node and connect the multiply output to the B input. Set the alpha to the scalar parameter from your material parameter collection, making sure the collection and parameter name match what we created earlier. Connect the final output to emissive color. This completes the X-ray vision material, allowing it to smoothly fade on and off based on your blueprint logic. Lastly, we need to add the post-process effect to the level. In the viewport, search for post-process volume and drag it into the scene. Scale it up very large so that it covers the entire level. This ensures the X-ray effect applies everywhere. Scroll down to the post-process materials section, add a new array element, and set it to the X-ray material we just created. This tells Unreal to use our material as a post-process effect in the scene. Finally, in the Details panel, enable Render Custom Depth Pass. Set the custom depth stencil values to 1 and 2. This allows the post-process material to detect which objects should be affected by the X-ray vision, giving you full control over what the effect highlights. And that's it! You've now got a fully working X-ray vision system inside Unreal Engine 5, all done with blueprints. If this tutorial helped you out, don't forget to drop a like, subscribe for more Unreal Engine guides, and let me know in the comments what mechanic you'd like to see next. Thanks for watching, and I'll see you in the next one.